All right, so some other water rights and a news source, but they had the question of, hey, we have a couple of these downtown wells that we want to increase the capacity on. What can we do? We want to put some larger pumps in there. We want to pump them a little bit harder, but is that something we can take a look at? And I recommended, well, as long as you're taking out the pumping systems, you might want to have a peek inside just to see what's going on. It may be worthwhile, bailing out or pumping out some of the debris that maybe have settled into the bottom of the well over the years. And these are screenshots from the video that we saw. That upper left corner there is the bottom of the well. You can see some equipment that had fallen in at the bottom. There was a fair amount of sedimentation that had accumulated in the bottom and plugging up the bottom part of the screen. The side views, the three other ones, show some pretty serious corrosion on a lot of the rods on the well screen. This is a continuous wire wrap well screen. It's the well's about 50 or 60 years old. And it was pretty heavily encrusted. So a lot of the flow is only coming through a small open area of the screen, and that actually ends up exacerbating a pre-existing problem that you may or may not be aware of, because you're drastically exceeding those fluid entrance velocities, which is causing more corrosion or more precipitation of some mineral incrustations and can compound some problems. So wells, for this particular provider, we were able to do some minor rehabilitation, but the age of the well, the condition of the well made us really nervous. We didn't want to brush it too hard. We didn't want to use some abrasive chemicals that could contribute to more of the corrosion and make it fail. So we ended up just doing a really light brushing with the nylon brush instead of a heavy steel brush, and being really aggressive. We just took a more subtle approach, and we were able to clean up some of it, but not all of it. But they were able to increase some of the capacity there. But they had no idea about the condition of the well. They were surprised when they saw it, and that just told us that some municipalities, some water providers are really good about tracking and monitoring performance, and doing some routine inspections and monitoring to see how that asset is changing over time and whether they need to make any changes. And that's something that we highly recommend, but also understand that communities are different. Some have a big customer base and a large pool of money they can pull from and help, but others operate on a much skinnier budget and don't have that luxury. And it could be a source limitation too, where they can't afford to take that well offline. They need that. That's their only reliable sources of supply. So it can get tricky. And so we try to help them adapt to whatever their needs are. But, wells are not just, holes in the ground with pipes stuck in them. They're more of an engineered a design for highly variable and unseen conditions. We don't know what's down there. Sometimes we can rely on existing well logs or other wells that have been drilled in the area to give us an informed decision about how we would design it and how deep it could go and what slot size we would be able to use to get the most efficiency out of the well. But they're not passive structures. It's kind of like monitoring the oil in your car and changing it regularly to get that extended life that you want out of your vehicle. If you ignore it, well, then the engine life is gonna not take you as far as you want to, and you'll be replacing that vehicle sooner than you would otherwise. So typical life cycle for a production well, I'd say in normal groundwater environments, 40, 50, 60 years. I've worked on wells that have biofouled before they even had a chance to build the facility. They drill the well, it takes 2 or 3 years for the facility to get permitted and constructed and built and connected. And by that time, there could have been some bacteria that makes its way in there for whatever reason. And, now they have a well rehabilitation plan that they got to implement before even putting the well into production. I've also worked on wells that are over 100 years old and are still functioning today. So there are some outliers there, but typically, 40, 50, 60, 70 years is a typical for most production wells. And the life cycle is, the planning and design portion. Find out where you want to construct it. Where do you need it? Where's some infrastructure? Where do you have land available? Get through the drilling and constructing phase, test it, get it online, and then you're through the operation and maintenance. And then throughout that time, some periodic maintenance and performance monitoring. And you may have to go in and clean it out periodically to optimize the performance and really get the most out of that asset as possible. And then at some point, as it gets older and older, it's harder and harder to maintain. You get a point of diminishing returns, and it just comes to a time where you just need to retire and replace it. And today, I'm just going to focus on the kind of the maintenance and the rehabilitation portions of it. So some of the problems that we typically see, I'll get a call from a client saying, "Hey, my well's not producing like it once was. Well, what's going on?" Well, okay, it could be a variety of things. It could be the pumping system. It could have just be old. The impellers might be worn. You could be pumping sand. It's not efficient. It's off the curve. There could be holes in the pump column. It could be leaky. It's not really producing like you would expect it to. It could be the aquifer. It could be declining water levels or seasonally changing water levels, where John had mentioned, the water column, the available drawdown. You want as much available drawdown as you can so that your pumping water level is maintained above your intake. Otherwise, you're going to be sucking air and you're not going to produce anything. Or it could be the well itself. If the screen gets plugged, then it's becoming less efficient. There's more drawdown. It's not producing like it once was. Or it could be a combination of some of these. I've just helped the city of Milwaukee. They are really good about monitoring or looking at doing some routine inspections. And through one well video that they saw, there was an old perforated well casing that the perforations ended up zippering open, and they had sand and gravel coming in, and they realized right away that, we have to shut this down or throttle way back on it and then plan for replacement. So that is a compounding issue where now it's pumping sand, maybe some gravel, and now you're causing some problems, some wear and tear on your pumping system. So what we'll look at is we'll go out and do a pumping test or a short flow test and see, have you experienced any decreases in your wire to water efficiency? Is there more of an electrical demand? Is it a pumping system problem? We don't necessarily want to take out the pumping system because that's costly. It takes the well offline. We want to see if we can do some diagnoses before getting to that point. So what are some indicators that could help us diagnose the problem without spending a lot of money up front? Have you noticed any groundwater level declines? Is your static water level deeper? You're losing that available drawdown capacity. So when you turn on your pump, as you would normally pump it, that pumping water level could get drawn down past your intake and cause it to cavitate. Have you seen any evidence of that? Or have you seen any changes in color or odor? Pulling a transducer out or replacing the batteries on it? Are you noticing slime or any biofilms on the cable or the sensor itself? Or have you noticed a decrease in the performance? And that's the specific capacity is one thing that we track or recommend our clients monitor to give them some sort of early indicator on a decline in the performance of the well, and there might be a problem going on. Specific capacity is the pumping rate divided by the drawdown. So at 500 gallons per minute with 10 feet of drawdown, that particular well performs at 50 gallons per minute per foot. So you have kind of a baseline threshold or baseline where you can compare maybe some recent pumping or from that baseline measure on. How does that compare to that old measurement? Are you seeing some steady declines over time? And at some point, it's not working like you need it to, and it may be time to do some brushing or bailing or swabbing or surging or something to reestablish that hydraulic connection between the aquifer and the well itself. And so that these dips in the curve here would be places where you would rehabilitate the well to get it back up to where it was once performing. But depending on where you catch that loss in performance, if you let it go too long, it's harder and harder to regain that lost performance. So if you were able to catch it earlier on the curve, you could change the projection of that sort of slow death of the well over time, and maybe flatten out that curve and get more out of the well over several more years than you otherwise would if you ignore the problem or you're not aware of it, because the longer it goes underperforming, the more difficult it is to rehabilitate it and get it back to where it once was. So that's where the performance monitoring and tracking really becomes important, because the earlier you catch it, the more likely you are to really be able to regain it. So we recommend a proactive approach, monitor and track that performance, do some routine inspections, pull the well or pull the pump periodically, have a look at it. Are there any issues? Do a video survey. Are you noticing any plugging in the screen? Are the slots still in place? Are you noticing any sand or gravel coming in? And if there's any flock or any evidence of slimes or biofilms, we would recommend, taking a groundwater quality sample and sending it in for a microbial assessment, where that would tell us the information that we would need to be able to design a chemical rehabilitation program targeted for whatever iron oxidizing or pathogens or bacteria that may have established in the well. But a lot of the times that's not the case. The purveyors may not have those resources available, or the time and the money it takes to do that. And we don't learn about it until the pump is damaged or the well is failing. And at that point, it's a little too late. And there really there is not a sort of a silver bullet solution to well rehabilitation. Every well is different. They come in all shapes and sizes in different geologic environments. They're operated differently. They're constructed of different materials. Their age could be different. The groundwater quality could be different. So you really have to factor that in to developing a rehabilitation program. Like I mentioned, the municipality earlier, when we started, we chose deliberately not to do an aggressive chemical and physical rehabilitation program because of the age and the condition of the well. We didn't want to damage it. They needed to use it, but we were able to, balance a little less aggressive approach and break up some of that stuff with keeping the well intact, still functional, and getting them what they needed. So, a common well is a filter packed well, where you have your well screen installed, and then it's encased in this envelope of sand, the filter packed sand that acts as kind of a pre-filter before that water enters into the screen. So when we design the screen, we'll design the size of the filter pack to hold back the formation, and then the screen slot size to hold back the filter pack to give it its most optimal and performing ability to really create as much efficiency in the pumping as we can. And that's really, a lot of it's dependent on, the different well screens that are used in wells. This one on the left is a wire wrap continuous. It has the most open area. It'll be the most efficient. Other types are, shutters or louvers, and you can just kind of tell from the picture that the open area is not as much as the wire wrap screen, and even less so than, the perforated well casing is even, less open area. So from a rehabilitation standpoint, getting that energy, imparting that energy out to break up any of the formation or any of the clogging is going to be a little more difficult in the perforated casing than the wire wrap screen, because it's more difficult to get that energy out in the formation to break up anything that may be plastered up against the side of it. There are natural packed wells where you don't need the filter pack. You can just depend on the formation itself. It's well graded, it's sand and gravel, it doesn't have fines. So the ability to do that is great. It saves on construction costs. It saves on well rehabilitation costs, because you don't need to get energy out past or through the screen and then out past the filter pack and out into the formation. And it just makes for a more efficient well. You don't have the head losses moving as the fluid moves through the slots and the screen. Hard rock or open borehole wells. This one shows that it's cased and sealed to a certain depth. And then it's just open borehole getting water from some of the fractures or joints in bedrock or the Columbia River basalt. Sometimes these wells have a perforated liner in them. It kind of depends on what the performance and the efficiency of the well, where the static water level is. You don't want to hang your pump in the open borehole portion, because if there's ever any caving or rockfall, now your pumping system is trapped down there. They might not be able to get it out, and now you've just lost your well and your pumping system. So under ideal conditions, you could hang your pump up into the case zone where it's protected. Otherwise, if that drawdown, the well is, the specific capacity is low, the performance is low, and your water level is being drawn down further, then we would recommend a liner be installed just to protect your pumping system. Larger wells, collector wells, these are riverbank filtration wells. These are 10, 20 plus feet in diameter, reinforced concrete with lateral well screens that move out horizontally from the bottom. And the picture on the left, you can see there's a couple of guys down in the bottom of this. This is like a hydraulic jacking system. There's a guy here with a yellow safety jacket on and a white hard hat, and he's running this hydraulic jack that pushes these the screens out laterally from the base of the collector well. And then the caisson wells are similar. The city of Spokane has a number of them. Taking a second while the picture loads. These are very similar to collector wells. They don't have the radial well screens, but the pictures on the right are from the well electric, a couple of the well electric caisson wells that were drilled. These are like 40 feet in diameter, 40 to 60, 80 feet deep. No screens, just open to the sand and gravel below. Very high producing, very efficient, very productive. The one on the left is the Hoffman well. That's brick lined, 6 to 8 feet in diameter up top, goes to maybe 12 to 16 feet at the bottom. That's like 200 feet deep, another big high producing well. So you can kind of see the different well types are going to dictate what sort of rehabilitation or restoration strategy you need to do. The collector well, you're probably going to need to send divers down in there to actually do the work. In a smaller, more traditional vertical 12-inch diameter well, there's some tooling that can be used to help with the rehabilitation. So let's say you have a problem, the well's not performing as you expected, now what? Well, you can do nothing and hope for the best, which we don't recommend. Diagnosing and preparing a targeted plan to repair or restore it, manage and protect your asset is what we would recommend. Or, hey, if this well has been problematic, you're having to rehab it more and more frequently, you may be coming to a point where, hey, we're tired of throwing money down this well. Let's just look at locating or replacing it, locating a new location for it, and abandoning it and drilling a replacement well. And that's a conversation that we have quite a bit with clients is, well, hey, I'm going to spend 10, 20, 50, 100, $200,000 on a rehabilitation plan, or do I take that and invest it into a brand new well? And you may not ever be able to regain that lost performance. So there is some significant risk in the decision making. So what you look at the history, if you do the performance monitoring and tracking, it helps you make that decision about, hey, this well has been a problem for years. Let's just move on and drill something new that's maybe more efficient, larger capacity, and stop wasting some of your money. Smart use of your resources. But we would come in and diagnose it. We would look at, okay, well, how have you been operating it? How much have you maintained it? What have you been doing? Have you noticed any problems over time? And if you have, what sort of maintenance history have you done on it? We would look at how the well is constructed. Is the seal intact? Is that contributing to some of your biofouling? Are you getting some surface water contaminants and pathogens that are making their way and then establishing themselves in the well bore? Or was it just poor development from the drilling contractor? Normally when when you drill the well, it damages the borehole walls. It creates this skin, and so you need to go in and develop that well and reestablish that hydraulic connection. And if the development was never done, that can contribute to a loss in performance over time, especially if the wells were drilled mud. They didn't really have a good mud program to get rid of that, and there was some residual mud left behind. You've sort of set the tone for the well not to be able to meet sort of its expected life performance. You've started at a lower level than you otherwise would if it was constructed and developed properly.
You're referring to driller's mud, correct?
Yes, driller's mud. Yep, that's right. Yeah, and oftentimes they'll use mud to hydrostatic pressure to float the cuttings up, keep the walls open, opposed to drilling and driving casing, because that can be time consuming and expensive. So we'll do a pumping test. We'll look at the performance. We'll monitor. We'll take a static water level. We'll turn the pump on. We'll track the production rate and the pumping water level. We'll look at specific capacity during that period. And, depending on what sort of history that water purveyor has, we can compare that recent specific capacity or well performance result to when the well was first drilled or when it was last rehabbed. And you can sort of get an idea of, okay, well, how's this well been functioning? Is it exhibited some performance declines for a long time, or how far are we off or away from its baseline performance, or what you would normally expect from this well? We would track some other pumping system parameters to see where we are on the curve. Is it a pumping problem? And this is all before we would even, crack open the well and do any in situ work. And then at some point, you may need to remove the pumping system and inspect it, do a video survey and see if there's any problems. Is there evidence of any biofouling? Can you see some silt or fines that are plugging up the slots in your well screen? That's all very, very informative. Has it filled up with sand or silt and it's blocking now 60% of your well screen? Let's go in and pump that out and clean it out and open up a little bit more open area for water to come in. And if we are seeing some evidence of any biological activity, let's take a groundwater quality sample and figure out, is it a physical plugging? Is it just silt, clay, residual drilling mud, or is it a biological plugging issue that would need to be addressed by a more targeted chemical rehabilitation program? So in developing the plan, you really look at your well type, know the condition of it. It could be an aggressive plan. In the case of, this was the city of Yelm in the Puget Sound area, we went to a much less aggressive approach. But the different sort of methods coarsely are mechanical rehabilitation. That's when you're just using a big brush to run through the length of the casing and scrub the inside of the well screen to break up some of that stuff that's a little harder to see. This is a really heavy duty wire brush. This is a little less abrasive wire brush. The bristles aren't as coarse. So there's different mechanical rehabilitations methods you can use. You can rawhide it, which is pumping the water up into the column and then shutting the pump off and letting that water fall back in if there's no check valve to, impart some energy into the formation and kind of break up and allow the water itself to break up any plugging that might be happening. Impulse generation is another technique that people are using. These are proprietary rehabilitation tools that can be used. Hydropulse or air shock is an example, and it's a tool that goes down the well and you can regulate the frequency and the magnitude of these bursts of nitrogen gas that help send out these big pressure pulses through the screen, through the filter pack, out into the formation to help break up some incrustation, loosen up some of the silt or clay that may be plugging it up. And oftentimes this is done in combination with some mechanical methods, and we'll oftentimes use some dispersants to help break up some of those fines as well. And it's important too to try to pump, if you can, pump simultaneously when you're doing this to remove some of the debris or the fines that you're creating. Otherwise, you're just pushing that stuff back out into the formation, and it's going to be more and more difficult to remove. So we highly recommend some simultaneous pumping, whether that's an airlift system or a submersible. That again kind of depends on how much space, how big the well is, how much space do you have to work with. And then there's chemical rehabilitation. If there's some microbes, some microbial contaminants that have established there, let's take a sample. Let's see if we can diagnose what sort of species they are, identify what would require to eradicate the population, whether that's just disinfectants or acids or biocides. What do we need that targets removal of those contaminants? And again, that's typically used in combination with some of the other methods. And expect and plan for change. Like I said, there's no silver bullet solution. Some wells respond really well, others don't, and it requires maybe several trips brushing through the entire screen column to really break it up and remove it. So performance monitoring while you're doing the rehabilitation is important so that you can track the relative improvements. So you do these specific capacity tests at the beginning, so you know how it's how it's performing now, and I can walk through the figure a little bit. That top little dotted line is kind of the baseline of specific capacity. That's how you would normally expect your well to perform. Well, you have a problem and you did your specific capacity test and you're way off the curve. You're way down here. So something's wrong. We need to develop a plan to try to restore that loss in performance. And by doing these tests sort of periodically through the rehabilitation plan, it lets you know where you are. Have you reached the performance that you would normally expect from the well, or you can use it to assess whether, brushing and bailing and surging didn't work. We need to go through something more aggressive. And as you go through the plan, you can see relative improvements in your specific capacity, and it'll help you decide, okay, we may not be able to restore all of it. We've gotten close. We're at a point of diminishing returns. We could stay out here for months and keep doing this. At some point, we need to stop just because we can't afford it. It's working. Let's stop. And that becomes kind of your new baseline performance that you would use to track any sort of the need for any subsequent rehabilitation or restoration efforts. But it's important when doing those specific capacity tests to really be systematic about how you're doing them. It depends on both rate and time. So if you pump at 500 gallons per minute for 10 minutes opposed to 100 gallons per minute for an hour, it's going to give you very different specific capacity results. So to be able to compare apples to apples and really assess the relative improvement, it needs to be comparable to each test. So try to pump it at the same rate for the same duration each time so that you can compare them and get a better sense of the improvements. And then document and reference. There's a lot of times where we hear, the well hasn't been performing. It hasn't been performing for a while. We'll go brush it and clean it. And we've done that a bunch of times, but they haven't documented. There's nothing we can go back on to really assess, okay, well, this worked and that didn't. So let's develop a plan that focuses on this and not that. Having that information is really beneficial. And then, wrapping up the recommendations, just know your well and your pumping systems. There's a lot of times where, 9 times out of the 10, purveyors don't know where their intakes are at even. Like what depth do they have them at? Are they in the well screen? Are they up shallow? And how vulnerable are you to groundwater level declines? Can you deepen your intake? We don't recommend putting the intake in the screen zone because that increases your fluid entrance velocities and causes more problems. Conduct routine inspections, do a water efficiency test or pull the pumping system and do a well video if you can to see if there's any indications of any problems. Monitor and the system performance regularly. Once, great. 2 years, twice a year seasonally would be better. Hit those seasonal groundwater level highs and those seasonal lows. That'll give you some information over time on is the aquifer recharging to the static that we would normally expect to see this time of year, or we're seeing sort of consistent declines in your groundwater level from these summer fall measurements year to year to year that would tell you we might need to deepen this well or come up with some other solution to address any loss in your available drawdown. And then consider the age and the condition of the well when developing the plans. Keep them active, try not to keep them idle for too long. And then, keep that pumping water level above the top of the screen if you can. A lot of the times the purveyors will just pump as hard as they can. And what that does is, again, it creates higher fluid entrance velocities because you're utilizing less of the screen, and that water's coming in at a faster rate that could exacerbate existing problems. So that's all I have. I'll just wait for questions to the end and I'll turn it over to Dan.